Okay, objective 3 now. So now we're going to use simulation to determine whether the difference between two means or proportions is significant. And again, this is very much a warm-up to chapter 8, I believe. Chapter 8 is about significance tests. Okay, it could be chapter 7. It's one of the two. One of them is about significance tests. And again, that's what we're doing here. We're just trying to measure whether a difference is significant or not. And again, you can see our note here. The theme of the year so far, this is huge. Differences that occur less than 5% of the time by chance alone are considered statistically significant. Remember, it is less than 5% on those dot plots that says, oh, it's too rare just to happen, so the fact that it happened is significant. I'll say it again. If it happens less than 5% of the time on those dot plot simulations, then that means that it is too rare to happen just by chance, and it's significant that it really happened. Okay, so again, I know it's a hard thing. It's counterintuitive, right? You want it to happen often, then it's significant. Well, no, in this case, we want it not to happen very often. That makes it significant. So it's just backwards thinking. All right, so this is broken into 2 slides. It says, example 3, what is distracting these drivers? Here are the results of the distracted driver experiment describing the first example. Calculate the difference in the proportion of students who stopped at the rest area in the 2 groups. So we are looking at those who stopped out of the passenger group and those who stopped out of the cell phone group. So my passenger group, 21 stopped. Here's the passenger group. 21 stopped out of 24. So 21 out of 24 minus, and in the cell phone group, 12 stopped out of 24. 12 out of 24. And we want to subtract those in Desmos geometry to get a proportion who stopped, or the difference in the proportion. So 21 over 24 minus 12 over 24. Okay, so let's go ahead and get out of here and go do that. Okay, so I'm going to erase this. Good. Okay, so go to Desmos graphing calculator. So it was 21 divided by 24 minus 12 divided by 24. And there it is, 0.375. Do not round that. That is a great, great fraction. Decimal, I'm sorry. Leave it. Leave it. So 0.375. So 21 divided by 24 minus 12 divided by 24 is 0.375. So that is the observed difference, right? So that means that 37.5% of the time, more people with a passenger stopped at the rest than cell phone. Okay, that's the difference. Again, if there was no difference, then those 2 fractions would be equal and the answer would be 0. 0 means no difference. That means no chance at all that having a cell phone or a passenger makes any difference in whether you stop. But because there is a difference here, this is saying that more people stopped with the passenger than with the cell phone. Less people are distracted with a passenger than are on a cell phone. You are more aware of your surroundings with a passenger than on your cell phone. What's the big idea? We'll see, but the idea I think is get off your cell phone, you kids who think it's okay to be on your cell phone when you drive. Focus on driving. I'm out there too. Just kidding, but focus on driving. All right, so keep that in mind, that 0.375. I'm going to write that on the next slide, right at the top here. So 0.375. That's the observed difference. Okay, so it says 100 trials of a simulation were performed to see what difference in proportions would occur due only to chance variation in the random assignment, assuming that the type of a distraction doesn't matter. Again, we're assuming that it doesn't matter. That is that 33 stoppers and 15 non-stoppers were randomly assigned to 2 groups of 24. Okay? So again, the 33 stoppers is the 21 that stopped in the passenger plus the 12 that stopped in the non-passenger or the cell phone. That's what they get the 33. And then the 15 is the total that didn't stop. And that'd be the 3 of the passengers and the 12 of the cell phone. There's where those numbers are coming from. So it's saying we're going to randomly put these people in groups because that would mean we're assuming that there's no difference. The type of distraction doesn't matter. And that's how we got these simulated differences. So we randomly assigned these people to groups. We then calculated the differences and we plotted it. And again, notice this middle line is 0. That is assuming no difference. That would be 12 out of 24, right? 12 out of 24 minus 12 out of 24 every time. No difference. And again, notice that really didn't ever happen, right? There's always less than or greater than 0. So you can see how unlikely that is. So again, use the results of the simulation on the dot plot to determine whether the difference in proportion from part A is statistically significant. Explain your reasoning. So the first thing is we focus on the 0.375, and if we want a difference, it's 0.375 or more, right? There's a direction, or more, because more would just emphasize more of a difference. So where is 0.375? Well, if this is 0.3, 0.375 is like over there. So the highest number is 0.3. 0.375 never even occurred. So this happens 0 out of the 100% of the time by chance. It happens 0% of the time by chance alone. There are no dots here to count. This is going to mean that the difference was significant because that 0% is less than 5%. This doesn't happen often by chance, and the fact that this actually happens in real life means that it is significant. That having a passenger versus a cell phone does make a difference in terms of how distracted you are. Okay, so here is how I'm going to answer it. In 100 simulations, a difference. So now I'm just reading off of here. A difference in the proportion of students who stopped. A difference in the proportion of students who stopped of, and now our observed value of 0.375 or more. And again, you could say occurred 0 times, or I'm going to say never occurred. So this is or more. Never occurred. That's 0 out of 100, which is 0%. So that's my first sentence. And again, that's very similar to how you answered a question, I think, in 3.3, if you remember from a couple quizzes ago. Therefore, now we're answering it just like, that's not therefore. Now we're answering it just like we did in objective 2. Therefore, the difference and again, because it didn't happen very often by chance, that means the difference was too large to be due only to chance variation, sorry, my spelling, I'll rewrite, to chance variation, those are important words, only to chance variation in the random assignment of treatments. So that's like objective 2, question 2. And then we just say, thus, the difference is statistically significant. The difference is statistically significant. Statistically significant. And I will finish it with 0% is less than 5%. Again, that number we're always supposed to, that percentage we're always supposed to compare to. Okay, so again, I hope you can see how this merges 3.3 and this section of statistical significance. So again, things that happen very rarely by chance alone are statistically significant. If this percentage was, say 10%, so there was 10 dots that had 0.375 or more, then we would say no. We'd answer the first question the same. We would just say it occurred 10 times. And then we'd say, therefore, the difference was small enough that it could be due to chance variation in the random assignment treatments. Thus, the difference is not statistically significant, and 10% is greater than 5%. Okay, so there's the idea. So hopefully that helps. Again, these are not easy problems, but I hope that you do well on them. And again, ask questions if you have them. All right, best of luck on the homework.